Good morning and welcome to a special edition of Be and Explore. Today I'm excited to have our guest, Dr. John McMaine from SDSU, who is going to talk to us about pervious and impervious surfaces. If you don't know what those are, that's okay because he will tell us what they are. And so good morning, John. Thank you for joining us this morning.
Good morning, Ann. Thanks for the invitation to be on. This is a lot of fun. I'm always glad to talk about things that I'm passionate about, and water and runoff and permeable and impermeable surfaces, or pervious and impervious surfaces, or some of those things. So to start with, we'll just cover some brief definitions. One of those is watershed. So what is a watershed? When I do this for classes, this is the first question I like to start with, because people don't necessarily know what a watershed is and if they live in a watershed. And so a watershed is just an area of land that drains to a certain point or a certain body of water. And so I'm here in Brookings. I'm broadcasting from SDSU's campus. And what watershed is Brookings in? Well, Brookings is in the Big Sioux watershed. Big Sioux watershed is part of the Missouri River watershed. Missouri River watershed is part of the Mississippi River watershed, which all drains to the Gulf of Mexico. So everyone is in a watershed, and everything that we do in a watershed affects someone downstream. And so that's what we're going to talk about today, how land cover and urbanization can affect what happens in a watershed. So the next question I like to go to is, what happens when it rains? What happens to the water? So you think about, it rained here yesterday in Brookings, and you think about what happened to that water. Well, some of it went into the ground, right? It went down into the ground, and that would be called infiltration or percolation. And infiltration is in undeveloped landscapes, so in prairie or in forest or meadows or pasture. Infiltration is the dominant thing that happens to rainfall when it falls on the ground. Most of it goes down into the ground as infiltration. Now, when the ground is saturated, or when the rainfall falls so fast that it overwhelms the ability of that ground to go down into it, then what happens to the water? Well, it becomes runoff. And runoff is just water that goes across the ground surface. It runs off. And then the third piece, which we're not going to get into today so much, is something called evapotranspiration. Now, you've probably heard of evaporation. That's the energy of the sun. It brings the water, the moisture, back up into the air. It's part of the water cycle. But transpiration is another part of that, and transpiration is the amount of water that's used by plants. So we know that plants use water, they take it up through their roots, and then they transpire it through their leaves. So when you combine those two, it's called evapotranspiration. So that's the third major piece of what happens on a landscape. Now, let's get to some more definitions. I want to talk about permeable and impermeable surfaces. Now, these can be interchanged with the words pervious and impervious. Really, there's no difference between the two. But permeable, what do we think that means? So we think of the root permeate, things like that. It means it can go into. And so a permeable surface is one that water can go into. So we think of, again, like our undeveloped watershed. So if you have a forest or a meadow or a pasture, these are all permeable surfaces. Now, the opposite of that, impermeable. Impermeable surfaces means the water cannot go into it. So this would be things like concrete or asphalt, a parking lot or a sidewalk or a roof. Is our roof impermeable? You bet it is. Otherwise, we would get wet every time it rained if we're in our house. So when you think about the three pieces, right? You have the infiltration, the runoff, and the evapotranspiration. If you go from a permeable watershed to an impermeable watershed, what do you think that changes? That really changes the amount of runoff that you see in a watershed. So we're going to do a little demonstration. We're scientists, and so scientists like to experiment, right? And so what we have here is we have 1 cup of water. This is going to be our storm size, okay? And so permeable surfaces are kind of like sponges. And so we have our 1 cup of water, and this is our watershed. It's a permeable watershed. It's made up of sponges. And so this again could approximate any kind of forest or anything else like that. And so we're gonna have our 1 cup rainstorm, and we're gonna see how much water is runoff versus infiltration, okay? And just to let you know, I have a little hole in the bottom, and that's gonna be our runoff. So infiltration is whatever's held by the sponges. Runoff is gonna be whatever comes out of the watershed at the bottom. So what do we think? Here we're raining on the watershed, on our permeable watershed. Got the whole 1 cup out, and we're just gonna shake it out, let it go down into the, well, really there's very little coming out. There's a little bit now. So I wanna be fair, I wanna make sure it all gets out the hole in the bottom. So this is about all the water that's come out as runoff. Okay. So let's just measure that since we're scientists here. Okay, so how much was runoff? Well, you can see that there's very, very little water in the cup, or in the measuring cup. So almost, we'll say maybe 5% of that 1 cup became runoff. And the majority of it, 95%, was infiltration. And this is what we expect to see in a permeable watershed. Okay, so now let's move on to an impermeable watershed. Now, underneath our feet, if we're in a building or if we're on a sidewalk, what's underneath our feet? Well, it's soil, right? It's dirt. It's what was there naturally, and soil is a permeable surface. But whenever we have urbanization, we cover that permeable surface with an impermeable layer. And so what do we think that does to our runoff? Well, let's just see. So we'll pour another cup here. Get another 1 cup measurement. Okay, so there's a cup. And again, we're gonna rain. This is our 1 cup size rainstorm, and we're just gonna rain here on the watershed. This is a pretty gentle storm, you know, it's nice and gentle, nothing too intense about this storm. And now we see some that stayed on top. So that's a smaller piece of the water cycle, but some of it is stored on the surface. And so you can see that we'll get all the water out just to be fair, like we did last time. And again, we'll make sure our measuring device, our measuring tool is open or is clean of any excess water. And then we will measure the amount of runoff that we had in this system. Okay, so we went from about 5% runoff in the permeable watershed to about 95% runoff in the impermeable watershed. Now, this is a big reason why we see a lot of, this is why we have to manage water in urban settings. And so that's why we have things like storm sewers and detention basins. But the storm sewer, it only manages localized flooding, and it doesn't do anything about the extra water that's in the system. And so that all ends up going downstream. And so whenever we have water going downstream, we think about what that can cause, right? So more water going downstream, one thing that could cause is more flooding downstream. So because of more flooding, or because of more water, we have the potential for more flooding. Another thing is you think about all the water that's in the stream. Okay, if you have a stream or a river, that stream or a river has developed under certain amounts of water, right? Historically, it's had certain amounts of runoff going into that stream. Now, let's say if we go from 5% runoff to 95% runoff, what do you think the difference is going to be for water in the stream? It's a huge difference. And so that could lead to other things like erosion, stream bank erosion, stream bed erosion. And so we could end up with more sediment in the stream. So even though this is a water quantity focused activity, water quantity can play a big role in water quality. So the amount of water we have going downstream leads to potential issues downstream. And so one of the ways that we manage this is through something called low impact developments. This is an umbrella term that essentially tries to get the hydrology of the watershed from where it is with 95, a runoff dominated system back to an infiltration dominated system. And one of the practices in that is something called a rain garden. And a rain garden is something that any homeowner or really anyone in the community could play a part in. And rain gardens next.
Yeah, I wanted to just bring up a picture you sent me of a rain garden and to point out some things here. This is you talking to a group of people. Thank you, Dakota Rural Action, for arranging to have a rain garden installed. And this is just somebody's backyard, if I understand. Is that correct?
That's absolutely correct. Yeah.
Okay. Can you tell me what's going on in this picture?
Yeah. So a little background on the project here. So this project was funded through a mini grant from the 319 Information and Education Program. And as part of this, we did 3 rain garden workshops. So we taught homeowners how to design and build a rain garden. They're pretty straightforward, but just to have a little guidance. And then we actually went and built a rain garden. So partnering with Dakota Rural Action. And what you can see in the picture, this is a tour that we did last fall. And so I'm over in the left-hand part of the screen, pointing to some of the features of the rain garden. And so what we have here is we have 2 separate cells, and this was to look at a little bit different treatments, if you will, from a research perspective. But within the rain garden, it's basically just a shallow ponded area. And so you can see the green berms, the berm I'm standing on, and then the berm across. So that's just the kind of the upper level of where the water would pond to. And then the lower level, you can see mulch, and then you can see native plants in there. So we have plants like milkweed and butterfly bush and Joe Pye weed and meadow blazing star, and all these beautiful pollinator plants that also serve a water quality function and a water quantity function. And so rain gardens, again, it's just a pretty simple shallow depression in a yard that you route any runoff from an impermeable surface. So this could be from a roof, it could be from a driveway. And then that runoff is able to be stored for about 24 hours in the rain garden, and it's allowed to infiltrate down into the ground. So we're getting back to that pre-development hydrology, that that runoff dominated hydrology versus, or the infiltration dominated hydrology versus the runoff dominated hydrology.
So this is a great picture. You think of just like a rain garden as being just a garden for rain to grow things, and just to use the picture as a demonstration. And I know this isn't the impervious surface that this rain garden is serving, but back here there is a roof, and when the rain falls on this roof, it doesn't go into the ground underneath the roof, obviously. Instead, it runs off, and so you have more rain coming onto the lawn and things like that. So what a rain garden would do is collect all that rain coming off of a roof, or like you said, a driveway, and put it into the rain gardens where it could stay for a little bit and then soak down into the ground. So how many rain gardens have been installed in Sioux Falls? Do you have any kind of number on that?
Not very many. The ones that I know of personally, I'd say it's under 10. So we're always looking for more, and there's interest. But yeah, we're still working on getting the numbers up.
So if somebody wanted to install a rain garden, what should they do?
Yeah, so first thing is figure out how much water you expect to get. And so if it's coming off of a roof, just measure your roof area. And then multiply that by an inch. So an inch or inch and a half to get a design storm. And that's your volume. And so then from your volume, if you know, okay, if you have a roof surface area times an inch and a half of rain, and you want your rain garden to be able to hold that amount of water, well, then you can design your rain garden with a similar footprint. We usually recommend anywhere from 6 to 12 inches of ponding. So having an overflow at the downstream end of the rain garden that's going to allow the water to go out. But then just go out. You want to be about 10 to 20 feet away from a foundation, so you don't force water down to a basement or into a foundation. But then it's just a simple matter of digging out your footprint, and then the earth the soil that you dig out from the footprint, then you can add that to the berms. You only have to go down, if you're doing a 6-inch ponding depth, might go down 6 inches and then add that to the sides, or 3 inches and then add 3 inches to the sides. So you split the difference there. But it can be a labor intensive process because you're out there with a shovel, but it's not too bad, and they're pretty straightforward technically. I mean, you're just taking water where it would just be runoff, and you're putting it in a place where it can go down to the ground. And then you end up with, so you add in plants that are going to have additional functions too. So it could be pollinator habitat for bees. It's going to be aesthetically pleasing, and this can all be done based on your taste. So if you prefer something that's more landscape looking, you can certainly choose plants that fit in that aesthetic. Or if you want something more native looking or natural looking, you can certainly choose plants that fit in that aesthetic. One thing about the plants is they're going to have times of inundation. So that's, since you're having ponded water in there, they need to be able to withstand wet feet. But then you're also going to have periods of dry periods in between there. Fortunately, a lot of native plants are built to withstand that. I mean, because that's kind of a natural process. You get saturation and then desaturation. And so fortunately, there's a lot of options that are able to withstand both of those conditions.
Do you have any technical guidance for someone who wants more than just a YouTube video? If somebody that we could put in our chat or in the show notes, or where would somebody go for step-by-step technical guidance?
Yeah, so we are currently working on a rain garden design guidance for South Dakota. neighboring states have some pretty good guidance. So Minnesota has a really nice plant list that gives you heights and how long they can withstand inundation. Really nice plant list. And then Nebraska, the city of Omaha is very progressive for stormwater. The Twin Cities are very progressive for stormwater. So we don't currently have any technical guidance for South Dakota, but that should hopefully be coming out within the next couple months.
Well, stay tuned and let us know. We'll circle back around and we'll put it in this video, and we'll might even have you back so you can talk about the technical guidance. So I think
that would be fantastic.
That would be awesome. So thank you so much. Thank you for anybody who is watching either currently or in the future. If you have any questions, put your comments and questions in the chat and we'll try to hook you up with John to see if he can help with those. Have a great day and stay safe.